If f of x equals the square root of x minus 5 and g of x equals 1 minus x squared, find f of g of x and g of f of x and their domains. We'll start by looking at the domains of f and g. The domain of g is all real numbers because it's a polynomial. The domain of f requires a little bit of calculation. Because we're taking the square root of something with a variable, we know that the radicand, in this case x minus 5, must be greater than or equal to 0. And so when we solve for x, this gives us x is greater than or equal to 5. Now that we've found the domains of the individual functions, let's look at the compositions. We'll start with f of g of x. We have to evaluate f of g of x, and g of x is 1 minus x squared. So we've got f of 1 minus x squared. And then f as a function takes the input, subtracts 5, and then takes the square root. So here we've got to take the input, 1 minus x squared, then subtract 5, then take the square root of all of that. Equivalently, we are taking 1 minus x squared and we're substituting it in for x in f of x. Simplifying the inside of the radical, 1 minus 5 is negative 4, so we have negative 4 minus x squared. So f of g of x is the square root of negative 4 minus x squared. Now, to look at the domain of this, we have to look at what happens to x. First, g is acting upon it, and that gives us 1 minus x squared. And then f acts upon that, giving us the square root of negative 4 minus x squared. Now, the domain of g is all real numbers. So we don't have any problem plugging in any numbers for x into g. That's going to work no matter what the value of x is. But now we have to look at what happens when we take 1 minus x squared and substitute it in for f. Now we know that f has a domain of x greater than or equal to 5. The input has to be greater than or equal to 5. In this case, the input is 1 minus x squared, so we need 1 minus x squared to be greater than or equal to 5. Let's try to isolate x squared to see what we get. If we subtract 1 from both sides, this gives us the opposite of x squared is greater than or equal to 4. We can then divide both sides by negative 1 to get the x squared alone. But remember, when we divide an inequality by a negative number, we have to flip the inequality sign. So this is going to give us x squared is less than or equal to negative 4. Now here's the problem. When we take a number and square it, the result will always be positive or 0. And positive numbers and 0 are never less than or equal to negative 4. It is impossible to pick an x value, a real number, square it, and get something that's less than or equal to negative 4. Because this is impossible, this will never work, this means that our composition of functions is never going to be defined. So in this case, the composition of functions, f of g of x, is completely undefined. There is no value of x where this composition is going to end up working. So it doesn't even make sense to say f of g of x is the square root of negative 4 minus x squared, because this is just never going to work out. This is why we have to be careful about domains. We can't just say that f of g of x equals the square root of negative 4 minus x squared and move on as though we've solved the problem and what we have makes sense. We've always got to look at our domains. Now let's look at the other composition and see if this works. G of f of x. In this case, we have to evaluate g at f of x. And here f of x is the square root of x minus 5. Now, because we're evaluating g at the square root of x minus 5, we have to look at g of x, and wherever we have an x, we have to replace that with the square root of x minus 5. So this is going to be 1 minus the square root of x minus 5 squared. Now we know that when we take the square root of something and square it, squaring cancels out the square root, and so this just becomes 1 minus the quantity x minus 5. But remember, we've got a domain issue when we do this, so we've got to be extra careful about the domain here. Now the last thing we're going to do is we're going to distribute that subtraction and combine like terms so that we can simplify this. That gives us 1 minus x and then plus 5, because when we're subtracting a negative, it turns into a positive. And when we add 1 plus 5, we get 6. So our composition of functions here is going to be 6 minus x, but we have to check the domain. So let's look at what happens to x here. First, f is applied to x, and that gives us the square root of x minus 5, and then that is inputted into g, and the output we get is 6 minus x. Now, we have to look at f and g and see what the domains are. We know that the domain of g is all real numbers. So here, we're not going to have any problems. All real numbers. G is an easy function. It will take anything as an input, so we don't have to worry about it. But f is a little bit finicky. We know that the domain of f is given by x is greater than or equal to 5. The input has to be greater than or equal to 5. And because the input is x here, that means x has to be greater than or equal to 5. Otherwise, we can't take the square root of x minus 5. So this is the restriction that we have, and so the domain is going to be the set of real numbers x such that x is greater than or equal to 5, and we can write that in interval notation as bracket 5 comma infinity parentheses. So our final answer is that g of f of x is going to be 6 minus x, and the domain of this composition of functions is going to be the interval from 5 to infinity. And there we go.